Hello, in this video I'll be presenting the introductory elements of chemistry to get you started into the whole concept of chemistry and how to use the certain tools and understandings of chemistry to help you in the future. So we'll start off by talking about the periodic table, which is a very iconic symbol of chemistry and you've likely seen it many times before. So there are 118 unique elements that have been discovered and added to the periodic table, and they're arranged in this fashion. And I urge you to use the periodic table as a tool throughout your chemistry career, throughout your studies of chemistry, to help you when you're dealing with certain problems, that you can use the periodic table to help you solve the problem. Because the periodic table is arranged in a very specific way for a very specific purpose. And so you can use the trends and the layout of the periodic table to help you with certain things that might come up. So the first thing we should probably go over is how to navigate the periodic table. So there's two ways you can navigate the periodic table. You can either go up and down, or you can go side to side. Now when you go up and down the periodic table like this that I just circled is called a group. You can also call it a column, but it's more specifically called a group. And elements that are in the same group tend to have similar properties or characteristics. So for example, this is called group 1A, and these are the alkali metals. And they all have similar properties in that the majority of them are soft, silvery metals that react violently with water. And so many groups in the periodic table, the elements within those groups share similar properties. So to go up and down, you go up and down a group. Now the other way to navigate the periodic table would be this way, going left to right. And if you were to go left and right on the periodic table, you're going across a period. So a horizontal element of the periodic table is called a period, hence the term periodic. And so periods are going to be very useful when you think of things like electronegativity and atomic radius. And this period that I circled in particular is of particular importance, especially in organic chemistry. So you'll be referring to this period in particular quite a bit. So that's how you navigate the periodic table. You just use either the groups or the periods. So when it comes to numbering these, you'll often hear groups referred to as specific groups. So this is 1A, this is 2A. We skip over these elements and we come over, see this 13, 14, 15. You can ignore this for the most part, because it's far more likely you'll hear these referred to as 3A, 4A, 5A, 6A, 7A, and this is 8A, but you don't normally refer to the noble gases that much. So this is typically how you hear groups referred to. Especially in general chemistry, you're dealing with a lot of nonmetals, and you're dealing with a lot of things in either group 1, 2, or from the P block. So if you hear something referred to as being in 7A, we're talking about this group here, not this group right here. So not that. We're talking specifically about 7A. Now I would, if you have your own periodic table, if I were you, I would probably mark this up as much as possible. The first thing I would mark on here is charge. So these groups tend to have charges associated with them. For the most part, certain elements within these groups have certain charges associated with them. So for group 1A is always going to have a +1 charge. So every element in this group has a +1 charge. Same can be said for group 2A. Again, we're going to skip over the transition metals. 3A is typically going to have a +3 charge. Group 4A is typically going to have a +4 charge. And then we skip over, we don't continue going in the positive direction, because now group 5 will typically have a -3 charge, group 6 will typically have a -2 charge, and group 7 will typically have a -1 charge. And keep in mind the noble gases have a neutral charge. They are not charged. So, with that out of the way, maybe we can discuss how these elements are broken up. So, overall, group 1 is called the alkali metals. Group 2 are the alkaline earth metals. This group of elements right here that we kind of skipped over are called the transition metals. And they're called the transition metals because they can transition between oxidative states, which means they can have multiple different charges depending on the situation that they're in. This group over here is sort of a cluster of different elements. You have nonmetals here like carbon, nitrogen, oxygen, and fluorine, sulfur, chlorine. You've also got metalloids like silicon, and you've got base metals like aluminum and gallium and lead and tin. And then you've got the noble gases also. So this group over here are called the noble gases, from helium down to radon. Group 7A you'll often hear referred to as the halogens. So fluorine, chlorine, bromine, and iodine are typically referred to as the halogens. Their ions, their charged atoms, are called halides. So if you hear the term halogen or halide, think group 7A. And then down here you have the lanthanides and the actinides, and these are your radioactive elements. These are your elements that you think of when you think of the nuclear industry, like plutonium and uranium. So that's just a brief overview of the periodic table, and we'll be coming back to this later when we discuss periodic trends and behaviors. So now let's come down. So we know that the periodic table is broken up into elements, and each individual element is represented in this kind of way. So you're given this, which is your atomic number, and this number represents the number of protons present in the nucleus of this atom. So we're dealing with hydrogen, which has 1 proton, therefore its atomic number is 1. Here we've got the atomic symbol. So the atomic symbol is based on the name of the atom. It's not always in English. Many of the atomic symbols are taken from the Latin names for these elements. And then on most periodic tables you'll have the actual element name, just in case you haven't memorized the symbol for each element. Most periodic tables will have the name of that element represented underneath the atomic symbol. And this right here represents the atomic mass, represented in AMUs, or which is the units associated with atoms. Atomic mass units. And this mass is the average taken from all of the isotopes that exist for this atom. And we'll talk about isotopes in just a second. So when you need to look up the mass of an element, this is the number you'll look for. Okay? So with that out of the way, so what is an atom? So an atom, of course, is made up of 3 subatomic particles, 3 major subatomic particles. These guys in white are called the protons, and they are associated with a positive charge. So protons exist in the nucleus of the atom, and they have an atomic mass unit around 1. Neutrons, which are these green guys, have a neutral charge, and they exist for the stability of the nucleus. And depending on the number of neutrons that are in the nucleus, that will depend on which isotope of an element you have. So different isotopes of each element have differing numbers of neutrons. And they have no charge. The last is the electron, which are these red guys, and they exist outside of the nucleus. They surround the nucleus, and they are associated with a negative charge. The outermost electrons, which are called the valence electrons, are the elements that are used for bonding. So the outermost electrons are the particles that take place in bonding. So the electron is incredibly important in chemistry because it is associated with the principle of atomic bonding, molecular bonding. And then we talked about isotopes a second ago. So isotopes are versions of an element with different numbers of neutrons. So here I've got two examples. I've got two isotopes of the two most common isotopes of bromine, which is a halogen. I've got 79 bromine and 81 bromine. Now notice how this bottom number is the same for both of these isotopes. That's because this number, 35, is the atomic number of bromine, which of course is its number of protons. The number of protons for an element will always be the same. No matter which isotope it will always have the same number of protons. So this number up here represents the number of neutrons in the atom, plus the number of protons. So this 79 includes this 35 down here, plus the number of neutrons, which in this case is 44. So there are 44 neutrons in this isotope of bromine. Over here we've got 81 total. So we've got 35 protons, 81 total, which means we have 46 neutrons. And that's how you can tell isotopes apart. And if you're ever in a situation where you have to figure out the number of neutrons in an isotope, just subtract the top number from the bottom number, and that will give you the total number of neutrons. So those are some of the basics of chemistry to kind of get you introduced into the concept. In the next video, we'll be talking about chemical equations and how to represent them in a reaction.